Hello students, welcome to the lecture on arithmetic, geometric and harmonic progressions. And after this lecture, we will be able to learn the following objectives. Explain the arithmetic progressions, discuss the geometric progressions, define the harmonic progressions, and let's start with the concept of arithmetic, geometric and harmonic progressions. An arithmetic progression or AP is a sequence where each new term after the first is obtained by adding a constant d called the common difference to the preceding term. If the first term of the sequence is a, then the arithmetic progression is a plus d, a plus 2d, a plus 3d, where the nth term is a plus n minus 1d. A geometric progression or GP is a sequence where each new term after the first is obtained by multiplying the preceding term by a constant r called the common ratio. If the first term of the sequence is a, then the geometric progression is a, AR, AR2, AR3, where the nth term is ARn minus 1. If we have the sequence 2, 8, 14, 20, 26, then each term is 6 more than the previous term. This is an example of an arithmetic progression, AP, and the constant value that defines the difference between any two consecutive terms is called the common difference. Let's now discuss the arithmetic progressions. The two simplest sequences to work with are arithmetic and geometric sequences. An arithmetic sequence goes from one term to the next by always adding or subtracting the same value. For example, 2, 5, 8, 11, 14 and 7 and 3 minus 1 minus 5 are arithmetic since you add 3 and subtract 4 respectively at each step. The number added or subtracted at each stage of an arithmetic sequence is called the common difference d, because if we subtract successive terms, we will always get this common value. Find the common difference and the next term of the following sequence: 3, 11, 19, 27, 35. To find the common difference, we have to subtract a pair of terms. It does not matter which pair we pick as long as they are right next to each other. 11 minus 3 equals to 8, 19 minus 11 equals to 8, 27 minus 19 equals to 8, and 35 minus 27 equals to 8. The difference is always 8, so d equals to 8. The next term is 35 plus 8 equals to 43. Since arithmetic sequences are so nice and regular, they have formulas. For arithmetic sequences, the common difference is d and the first term a1 is often referred to simply as a. Since we get the next term by adding the common difference, the value of a2 is just a plus d. Third term is a3, which is a plus d, which is equal to a plus 2d. The fourth term is a4, which is a plus 2d plus d, which is equals to a plus 3d. Following this pattern, the nth term will have the form an equals to a plus n minus 1d. Example, the nth term and the first three terms of the arithmetic sequence have a6, which is equals to 5, and d equals to 3 by 2. The nth term of an arithmetic sequence is of the form an equals to a plus n minus 1d. In this case, that formula gives me a6, which is equal to a plus 6 minus 1 into 3 by 2, which is equal to 5. Solving this formula for the value of the first term of the sequence, we get equals to minus 5 over 2. Then a1 equals to minus 5 over 2. a2 is equal to minus 5 over 2 plus 3 over 2, which is equal to minus 1. a3 is equal to minus 1 plus 3 over 2, which is equal to half. And an is equal to minus 5 over 2 plus n minus 1 into 3 over 2. Sequences. It is a set of numbers which are written in some particular order, or a sequence is a set of numbers which is written in a particular order. We sometimes write u1 for the first term of the sequence, u2 for the second term, and so on. We write the nth term as un. For example, take the numbers 1, 3, 5, 7, 9 and so on. Here we seem to have a rule. We have a sequence of odd numbers. To put this another way, we start with the number 1, which is an odd number, and then each successive number is obtained by adding 2 to give the next odd number. Here is another sequence: 1, 4, 9, 16, 25 and so on. This is a sequence of square numbers, and this sequence 1 minus 1, 1 minus 1, 1 minus 1 and so on is a sequence of numbers alternating between 1 and minus 1. In each case, the dots written at the end indicate that we must consider the sequence as an infinite sequence so that it goes on forever. On the other hand, we can also have finite sequences. The numbers 1, 3, 5, 9 form a finite sequence containing just 4 numbers. The numbers 1, 4, 9, 16 also form a finite sequence, and so do these numbers 1, 2, 3, 4, 5, 6 and so on till n, sum of an arithmetic series. The sum of the terms of an arithmetic progression gives an arithmetic series. If the starting value is a and the common difference is d, then the sum of the first n terms is Sn equals to half n into 2a plus n minus 1 into d. If we know the value of the last term b instead of the common difference d, then we can write the sum as Sn equals to half n into a plus b. Sometimes we want to add the terms of a sequence. What would we get if we wanted to add the first n terms of an arithmetic progression? We would get Sn equals to a plus d plus a plus 2d plus so on and so forth plus b minus 2d plus b minus d plus b. Now this is now a series, so we have added together the n terms of a sequence. This is an arithmetic series and we can find its sum by using a trick. Let us write the series down again, but this time we shall write it down with the terms in reverse order. We get Sn equals to b plus b minus d plus b minus 2d and so on plus a plus 2d plus a plus d plus a. We are now going to add these two series together. On the left hand side we just get 2Sn, but on the right hand side we are going to add the terms in the two series to each term in the first series will be added to the term vertically below it in the second series. We get 2Sn equals to a plus b plus a plus b plus a plus b and so on plus a plus b plus a plus b plus a plus b. And on the right hand side there are n copies of a plus b, so we get 2Sn equals to n into a plus b. But of course we want Sn rather than 2Sn, and so we divide by 2 to get Sn equals to half n a plus b. We have found the sum of an arithmetic progression in terms of its first and last terms a and b and the number of terms n. We can also find an expression for the sum in terms of the a and the common difference d. To do this, we just substitute a formula for b into formula for Sn. From b equals to a plus n minus 1 into d, Sn equals to half n into a plus b. We obtain Sn equals to half n into a plus n minus 1 into d, which is equal to half n into 2a plus n minus 1 into d. For example, find the sum of the first 50 terms of the sequence 1, 3, 5, 7, 9 and so on. Solution. This is an arithmetic progression and we can write down a equals to 1, d equals to 2 and n equals to 50. We now use the formula so that we get the value of S, arithmetic mean or AM. When three A's, small a, capital A and B are in capital A, P, then A is called the arithmetic mean of numbers A and B. We have capital A minus small a equals to B minus capital A or capital A equal to a plus B by 2. Thus, the required capital AM of two numbers A and B is a plus B by 2. Consider the AP, which is 3, 18, 13, 18, 23, 28 and 33. There are 5 terms between the first term 3 and the last term 33. Those terms are called arithmetic means between 3 and 33. Consider another AP, 3, 13, 23, 33. In this case, there are two arithmetic means, 13 and 23 between 3 and 33. Generally, any number of arithmetic means can be inserted between any two numbers a and b. Let a1, a2 and a3 and so on till an be n arithmetic means between a and b. Then a1, a2, a3 till an b is an AP. Let d be the common difference of this AP. Clearly, it contains n plus 2 terms. These are required n arithmetic means between a and b. Adding 1, 2 and so on till n we get. Now moving on to the next topic, we will study the geometric progressions. A geometric sequence goes from one term to the next by always multiplying or dividing by the same value. So, 1, 2, 4, 8, 16 and so on, and 81, 27, 9, 3, 1 and 1/3 and so on are geometric since you multiply by 2 and divide by 3 respectively at each step. Find the common ratio and the seventh term of the following sequence: 2 by 9, 2 by 3, 2, 6, 18. To find the common ratio, we have to divide a pair of terms. It does not matter which pair we pick as long as they are right next to each other. The ratio is always 3, so r equals to 3. Then the sixth term is 18 into 3, which is equal to 54. And the seventh term is 54 into 3, which is equal to 162. For geometric sequences, the common ratio is r, and the first term a1 is often referred to simply as a. Since we get the next term by multiplying by the common ratio, the value of a2 is just ar. The third term is a3, which is r into ar, which is equal to ar2. The fourth term is a4, which is equal to r into ar2, which is equal to ar3. Following this pattern, the nth term an will have to form an equals to ar into n minus 1. A sequence of numbers in which the ratio of any term to the term which immediately precedes is the same non-zero number other than 1 is called a geometric progression or a GP. This ratio is called the common ratio, geometric mean. If a, g, b are in GP, then g is called the geometric mean between a and b. If three numbers are in GP, the middle one is called the geometric mean between the other two. If a G1, G2 and so on till Gn, B are in GP, then G1, G2, Gn are called in GMs between A and B. The geometric mean of n numbers is defined as the nth root of their product. Thus, if A1, A2 and so on, An are n numbers, then the Gm is given by as shown on screen. Let G be the GM between A and B, then A, G, B are in GP. Relationship between AM and GM. Let A and B be the two numbers. Let A and G be the AM and GM, respectively, between A and B. Arithmetico-geometric series. A series each term of which is formed by multiplying the corresponding terms of an AP and GP is called arithmetico-geometric series. The general or standard form of such a series is A plus dr, A plus 2d r2 and so on. The sum of first n natural numbers. Let Sn or sigma n square denote the sum of first n natural numbers. Then we have as shown on the screen. The sum of squares of first and natural numbers. Let Sn or sigma n square denote the sum of squares of the first n natural numbers. Then we have the sum of cubes of the first n natural numbers. Let Sn or sigma n cube denote the sum of the cubes of the first n natural numbers. Then we have method of differences. In some series, the differences of successive terms t, tn and tn minus 1 may be in some particular sequence minus ap, gp, agp, etc. In these cases, the sum of series can be found by a technique known as the method of differences. Let's know the meaning of harmonic progression. If a sequence is in AP, then the sequence obtained by taking the reciprocal of every term in the sequence forms an HP. That is, if A, B, C and so on form an AP, then 1 over A, 1 over B and 1 over C and so on form an HP. The progression A1, A2 and A3 and so on is called an HP if 1 over A, 1 over B and 1 over C and so on is an HP. Let A, B, C form an HP, then clearly 1 over A, 1 over B and 1 over C form an AP. In this case, B equals to 2AC by A plus C, where B is called the harmonic mean. Problems related to HP are generally solved by converting it into an AP. Now in the end, let us summarize what we have learned in this lecture. An infinite sequence where each term from the third term onwards is obtained by adding together the two previous terms is called the Fibonacci sequence. An arithmetic sequence goes from one term to the next by always adding or subtracting the same value. A sequence is a set of numbers written in a particular order. The sum of the terms of an arithmetic progression gives an arithmetic series. If the starting value is A and the common difference is D, then the sum of the first n terms is Sn equals to half n into 2A plus n minus 1D. When three numbers A and B are in AP, then A is called the arithmetic mean of the numbers A and B. We have A minus A which is equals to B minus A, or A equal to a plus B by 2.